thank you so much. And hello, PythonAsia 2026. So it's fantastic to be here. It's my first time in Manila and also in the Philippines as well. So just a quick introduce myself. I'm Greg Tennyson Jansamret. I'm a solution architect at Amazon Web Services or AWS. I'm based in Bangkok, Thailand, and I just flew yesterday. So I'm with the Amazon about 4 years right now. Start from 2021, from intern into the solution architect. And the fun fact about me is I'm the solo traveler and the cat lover. So yeah, so let's get into it. So about this session is the topic is the agentic system is the full stack for developer. So we all know the term of the full stack, right? So well, in the next 30 minutes, I want you to set that definition aside because today we will talking about the massive evaluation and agentic system. So it's not some far away from the science fiction concept, but it might be the new architectural layer that we are going to build. And the best part is that the Python is the right heart of it all. So here's the plan for today. So I will start with the looking at the big picture, how the full stack is changing. And then we will connect the dot from the event-driven that I think everyone know and we love the event-driven architecture, right? And move from the event-driven into the new cognitive one. And after that, we will get into the practical. We dive into the Python toolkit that I bring today. There's the new way of the working that called spec-driven development. And finally, we will tackle the thought stuff to combine all of those things to deploy into the production. And let's see what it all mean for you. So let's go. So the evolution of the full stack. So let's jump in. The definition of the full stack has never really still, right? So it's always moving a target. I mean, when we move from the classic LAMP, right? We have the Linux, we have Apache, we have MySQL or PHP or whatever, right? And then each the next one is like we have moved into the modern web architecture. Like we have the JavaScript framework, we have the API, the NoSQL, or even the CI/CD, right, in the last decade. And then we move into the cloud era that we introduce the infrastructure as a code. We have the serverless or even the event-driven architecture that I mentioned. And today we are right now standing on the edge of the chip is that the agentic layer that I'm going to talk about it. So this layer, the agentic is not probably the most important point that I'm gonna make today because you see that the agentic layer here is doesn't mean you need to throw away the cloud or skill, the modern web skill, but it means that the agentic is built on top of it. So what is the exactly agentic system? So into the clear definition of it. So it's really boiled down to the 5 ideas. Start from the goal-oriented. So it's get the mission into the agent, right? There's no need to be defined the step by step into the agent, but we have the mission that will let the agent to be finished first. And then the agent start to planning and start to reasoning. So how to achieve that mission that I give into the agent, and then we'll break it down into the small step, right? And then after it's break down into the small step, the next one is the tool use. So the tool use is that like the function that we might call the API, call query the database, or even the run the shell. And the next one is the ability of the autonomy. So the agent will have to decide what to do next, right? And then the last one is the adapt. So what if it go wrong? So the agent should be adjust the plan, not just the crash, right? And then get the new info and it's going to be in the loop in here. So like not just only, this one is just the example that is not just only call the single shot of the LM and then get the output, right? But it will be in the flywheel of the reasoning, the plan, think again, use the tool, and then do this thing again. And the another example is that like when moved from the event to the cognitive one that I mentioned, this is the example of the event router. Like in the traditional way, we might have like the message, and we have the event router that might act like the switchboard, right? So it might come with the predefined header, the tags, everything, and then do the thing that already predefined, like the rule base. But the agentic one is act like the regional project manager, I can say. Like it will use the capability of the LM to get the user intent and to get the reasoning what to do next, right? So if I compare with the traditional one from the event-driven pattern that we all know to the agentic system equivalent, right? Like if we have the static rule-based routing, so on the agentic system it will be the semantic intent routing, or even the fan-out message processing, right? We send the message into each step, right? But on the agentic, there will be the swarm pattern collaboration that I will mention later on this session as well. So you might wonder that like how this relate into the Python or cloud service that you already use nowadays. So this one is just the map that I just mapped that how the agent concept compared to the Python or even the cloud or AWS analogy. Like you have the tool on the agentic, so it can compare like you using the Lambda function or microservices or even the function on Python that I think you all might code it 1,000 times, right? Or the memory one. The memory on the agent can be back to the database on the cache on the state that you already work with it. The policy and guardrail to protect the agent, to protect the input and output of the agent, right? The response. So it can be the IAM policy of the cloud or even the schema validation that you already know about it. And the agentic loop is like can compare back to the step function or orchestration flow. So here's the main part of the session today is about the Python agent toolkit. So let's go into the standard and framework. So recently we heard a lot about the MCP, right? So MCP stands for the Model Context Protocol. Is act like the universal USB-C port that for the AI agent that can just plug and then able to use, or even the other just plug in and able to use our system as well. So inside the MCP is use the tool to here's the thing that we will need to have for the MCP. The first one is the tool. The tool is the can be the execute function to do the action, right? And then we will have the resources for the agent. The resources can be like the library for the agent that the agent will take a look and then see what is inside the resource that they have and then pick the right resource. And the last one is just the prompt. The prompt is you can think like the reusable template to shaping how the agent will behave. So like we all know that when we prompt the agent, like you are the assistant to do 1, 2, 3, 4, right? So back to the Python one. So in the Python, as I mentioned, as you already write the function, right? You can just nowadays those of function in Python you can just use the decorator of the framework that I bring today is called add2 to be on top of your function. So it can be just use your own function with the add2 here, and then add2 here will work as a tool in the agent system. So here is the strand agent. Not sure everyone in this room, have you heard about the strand agent yet? Not yet? Okay, okay. So the strand agent is the open source from AWS, is the SDK, Python SDK. The concept of the strand agent is just let you build the agent with a few lines of code. So right now is the SDK support Python, and in last December, I think they just support the TypeScript as well. So before I go into the how the strand agent work, so I might talk a bit about the agentic loop. So it's how the strand agent work behind, right? So the agentic loop here is we try to use the ability of the LM to give the reasoning. For example, like when user give the input, right? So the LM will process using the LM to process the user input and try to see what is the user intent and decide which tool they will need to use, right? And then as we'll use the LM to think which tool to use the tool to do the action. And then after it did the action, as we'll get the response, right? And then we'll use the LM again to observe the result of the action, and then if it's okay with the user intent, so just send back to the user to generate the final response here. So here is the concept of the strand agent. So you can think like this in the loop here, like why not done. There's the 3 sub-step here. The first one is think. So inside the thing here is we will use the LM to think about what is the user intent. And then the next one is maybe used to which tool the agent need to use to do the action. And then the last one is after is get the result from the tool, we will use the LM again to observe the result of it, and it will do the loop here until it's finished. So in the strand agent, as I mentioned, it's actually the open source, so you can use with any model, like from any model provider. It's not just only from Amazon for sure. So like in here, you can use the model from Amazon, or even you can use model from the OpenAI, from the Google as well, or even on your own local machine as well, so it's able to use. So about the tools, or the tools that Strand Agent that are able to use, as I mentioned, this framework is the Python based, right? So, and the Python community is yeah, we can see there's a big community here. So as I mentioned, every function that you write in Python, you can use with the add to declaration on the Strand agent, and it's convert into the tool of the agent here. So here is how the easy that I told you there's just only a few lines of code that you can create your own agent. So in here you can use code, right? The from stand import agent, and then from stand agent tool, you can just import the tool that you want to use. In here, just use the calculator, use the HTTP request, and use AWS. There's only 3 tools for now. And then when I want to write the agent, I just write only in, I can say like in 3 lines here. So the agent justify, the first one is model, which model you want to use. The tool you want to use for this agent. For this one, I will use these three tools. And just only the prompt, the instruction here. The instruction here, the agent that I want to build here is just the assistant to calculate the number and able to pull the data from the API. So when I use this agent, or I just type into the agent, right? Like just calculate the number, the expect behavior of this agent must be use the tool calculator. Or if I tell my agent that I want to pull the data from the API, so the behavior of this agent will use the HTTP request here. So about the tool, there's a lot of the available tool right now on the Strand agent. So you can see that they have the rack memory option to work with the file operation, or even you can use the AWS service. You just use the tool that use underscore AWS to interact with the AWS services inside. And the main thing here as well is about the agent and workflow. So here's the list of the tools that are already available, right? So let's see about the multi-agent pattern here. So in many use cases that I work with many customers in Thailand, there's a unique use case that they are building their own agent, right? So start with the workflow, easy one. The workflow is like the deterministic step that like we can define like 1, 2, 3, 4, right? Just like the waterfall one. The next one is the graph pattern. The graph pattern is about like you might do the thing in parallel together and then just come back to do summary or do something, right? And the last one is the swarm pattern. So I will go in deep one by one. So the first one, agent as a tool pattern. So this one, you can see from the architecture here. So you can have like the orchestrator agent one, and then able to send the task into the sub-agent. So in the sub-agent here, you can use the agent as a tool as well. It means that this one you build for sub-agent, but you use the agent as a tool. So it can be like agent as a tool here. The second one, the graph pattern that I mentioned is here. So like the scenario here is that like what if the multiple expert want to work independent, like need to do something in parallel independent, and then we'll make a final decision at the end. So here's the example, like the financial advisor here. I will do the technical architecture and market researcher together in parallel. So it's no need to wait the other to finish first and then in here. And then at the end, it can just back to the risk analyst agent to analyze two agents together, right? And the last one here is the swarm pattern. So for the swarm pattern is the pattern that is like the bee working together. So you just throw the user intent into the agent, right? Inside the agent here, you don't need to define which agent you need to working first or later, but it will use the capability of the agent of the LM to decide which node of the agent will work next one. For example, I give the instruction to the agent that I want to plan the 3-day trip in Manila. So in the agent, it will go work independent, go to the research first. After the research finish, it will hand off to another agent. And then after finish, it will get the final response back. So that is the part of the agent, the workflow, and the tool, which is the Strand agent. So you can just try with the SDK on the GitHub right now. And so now let's just move a bit into the spec-driven workflow. So from code to spec, as I mentioned, we pass a lot of the movement of the full stack, right? So here's the top of it about the agentic system. So in here, in the traditional way, we work as we planning design, we implement, we testing, doing Q&A, and then we deploy, right? So in nowadays, there's a tool that already come in and able to help us to do the practice of the software development lifecycle here with the spec-driven development, which means that we just write the spec what we want to do and then let the RM help us on this. But it means that we are not going to let the AI do everything for us for sure. So here's the hero just checking again. Is anyone in this room heard about the hero? Oh, okay. That's a lot for hero for now. So here's how the hero working. So I will just play the example here. So in the hero, we just send in the I can say the prompt or our requirement into the hero, right? And hero will break the user intent or our prompt into the spec here. So we can see there's the requirement document first. And then after the first requirement, after we review all requirement, it will turn into the design phase. So in the design phase, it will align with the requirement that we write already, and then turn into the task list, and then we'll let the RM and AI doing the task list to follow the design and follow the design the requirement that we already write here. Okay, so one thing this one just only adding is that the Kiro is actually now is available in the terminal as well. So you can just call like Kiro CLI and then work with the Kiro in the same way with the IDE previously. All right, and the last one is about the how after we build the agent, after we like turn our intent, like writing the spec, have the software development one, right? And how we turn those into the production, right? So from like I can say like 2 or 3 years ago, like I work a lot with the customer on the agentic AI, but the thing that cannot make them from the POC into the production is like uh, about their observability and the security things. So here's the traditional way that we use the observability, right? We trace the stack. We see the error rate, like is it going up a lot of the error, or even we monitor the CPU or memory utilization. So on the agentic observability things, are we move or we shift the paradigm to trace on the reasoning trace, or we use like how many of the two failure rate and even the retry rule, so we can see which part of the agent that might make our agent slower or even failure, right? And for sure, from the cost or uh, that we track the CPU or memory utilization, so we shift into the token consumption usage or and cost attribution as well. So here's just the thing that are actually from the strand agent, you can just use the observability feature that you can use the metric of the token usage to track the performance, the to usage, or even the loop cycle of the agent as well. And you can just trace the entire agent life cycle as well. And the last thing is just only the deployment. So Strand Agent is the Python SDK, right? So if you want to deploy this agent into your production, you can just deploy Strand Agent anywhere that Python can run, which means that you can run on your own local machine, you can run on cloud, or even you can run on the behind the API, or even in the other cloud as well. So it's easy to use, and it's the open source here. So one last thing is the key takeaway. So I think right now Python is like the bridge of the data and the machine learning that we work now today, right? And into the agentic system, the layer that I think is going to be the new stack, like on top of the full stack right now. So I think we are in the good part right now. So the key takeaway is the agentic layer stack is happening right now, and it's actually built on top of your event-driven architecture expertise that I already compare on the table, and Python 2 are here today. And the last one is the message is that the production is different, but you have the foundation to lead this change. So yeah, thank you so much.